How to use the slope formula. Well, this is more of a review than anything else, but it's very, very important to what we're going to be doing for the next couple of weeks. Using the slope formula. We're all familiar with the formula m, our slope, is equal to a fraction. On top of the fraction, in the numerator, we have y2 minus y1 over the denominator, which is x2 minus x1, or otherwise known as the difference of our y values over the difference of our x values. Now, why do we have this little 2 and this little 1 and a little 2 and a little 1 over under the x's and the y's? Well, those are known as subscripts. Those help us know the difference between the first and the second y values and the first and second x values. Because we use the slope formula when we are determining the slope or the average rate of change given 2 points. So therefore, we need to be able to differentiate, know the difference between which are our x and y's of the first point and which is the x and y of the second point. Well, therefore, one of the first things that I like to do is when I am given 2 points, I like to write them down. Well, I already have them written down. It's the graph of the line passing through the points 6, 7, and 4, 2 has a slope of, right? We're going to find the slope. Well, I'm going to call this first point, 6, 7, my first x and my first y. Sometimes I go right across and say, well, that's an x and that's a y, like all points, which means this over here is my second x and this here is another y. I'm going to go back, and since this was my first point, this was my x1 and this was my y1. And this is my second point, so this is my x2 and this is my y2. Now, a lot of people ask the very good question, well, what if I decided that 4, 2 was my first point and that 6, 7 was the second point? Well, if you label them that other way and you do everything right, you should get the same exact answer at the end. Well, let's take a look at the process. When I first teach how to use the slope formula, one of the things I like to do is after I have the slope formula written, is to rewrite it as a long fraction. But everywhere where I see an x1 or an x2 or a y1 or y2, I'm going to put parentheses. So I'm going to start here on the top left, my y2. So there's a parentheses, because I'm going to substitute my y2 there. And this helps me not forget to put this negative there, right? The subtraction sign. And then I'm going to open up my other parentheses for my y1. And then on the bottom, I'm going to do the same. This is where my x2 is going to substitute, and this is where my x1 is going to substitute. And now I go back and I take a look at my point. I say, well, what is my y2? Oh, I already have it labeled. My y2 is 2. And what is my y1? Well, it's over here, and that's 7. And then what is my x2? I can see that's 4. And what is my x1? That is 6. Well, okay, well, I got the substitution part in. Well, now I'm going to put another equal sign and another fraction line. And you could use your calculator if you like, or if you're good at adding and subtraction, no problem. So here I have 2, positive 2 minus a positive 7. 2 minus 7 is negative 5. And then 4, positive 4 minus a positive 6, or 4 minus 6 is going to be negative 2. Now, at this point, you might know how to simplify that, but there's nothing wrong with bringing up our calculator just to check here, because whenever we're doing slope and we have fractions or decimals, we want to always simplify them. I'm going to put a negative 5 divided by negative 2. Now, I happen to know that a negative divided by negative is going to be positive, so I'm going to have a positive slope. And I'm going to hit enter, and I see I have a decimal that is positive. Now, that might be an answer, say, in a multiple choice question. They might leave it in decimal form, but usually we put that back into a fraction. So I'm going to go to math and hit enter twice. And I say it's 5 over 2, positive. So I'm going to put equals to positive 5 over 2. And that's the answer. The slope of the line that would pass through both of those points is going to be positive 5 over 2. All right, let's do one more example, and you could pause your screen and see if you could do it from start to finish. Here's the other example. And what I'd like you to do is to write down the formula, write down the parentheses, and do the process exactly the way I just did it. You might notice there's a lot of negative numbers in there, so it's really going to be helpful to use the parentheses method. Okay, let's take a look. Number 2, what is the slope of the line determined by the points 5, -3, and -9, -6? Well, when I'm determining the slope based on 2 points, I like to start sometimes on the top of my paper. You always should state the formula at least once. So since I can't see the other one, I'm going to write down the formula again. My m, my slope, is my y2 minus my y1 all over my x2 minus my x1. And like I stated earlier, I do like to open up parentheses for all of those places, especially when I have negatives. It's really helpful because one of the biggest mistakes we make determining slope is the sign at the end. Very common mistake. So now I'm going to go back. I see my 2 points. So I'm going to go from left to right. Say, well, the first number inside the parentheses is going to be my x value, and the second one's going to be my y value. The first one's going to be my x value. The second one's going to be my y value. Now I'm going to go back and say, well, this was my first point, so this is my first x and my first y. And this is my second point, and this is my second x and my second y. Now I'm going to come back and I'm going to substitute them where they belong. Well, the y2 is my -6, and my y1 is -3. My x2 is -9, and my x1 is +5. Now, here I am going to recommend that you use your calculator because it's good practice to try this in your head. I happen to know that -6 minus a -3 is going to be equal to -3, but I have a lot of practice in that. So let's see how we would do that. Well, there's a couple different ways you can go about it with your calculator. First of all, you can always use the parentheses and put it exactly the way you see it. Remembering inside the parentheses, I use the negative underneath the 3. So it's -6. And then when it's outside the parentheses, it's the subtraction button. And then I go back to the parentheses to put my another -3 inside. And then I hit enter, and I was right. It's -3. So I'm going to come over here and write -3 for my numerator. And then on the bottom, we have -9 minus 5, which is going to be -14. But let's just double check. Right? We're practicing with the calculator. Now, let's see. Parentheses, -9, parentheses, minus parentheses, just a 5. And we hit enter, and we see that that is -14. Now, as far as simplifying goes, if we have our calculators handy, why not use it? So I'm going to put a -3 divided by -14 to see if that could be simplified. Well, we should all remember that a negative divided by negative is going to change to a positive, but it's going to give me this crazy decimal. Well, I don't like the decimals. I prefer fractions. So I'm going to go about math and hit enter 2 times. Enter, enter. Oh, see that? Well, the only thing we needed to do to simplify that was change it to positive. 3 over 14. So our slope is going to be +3 over 14. Now, as we are learning, the slope formula is really pretty much exactly the same as the average rate of change. And since this is a regions class, let's take a look at a regions question where they're giving us, say, kind of like a piecewise graph, right? You can see the line is kind of changing its slope at all of these different points, which means that the average rate of change between any 2 points is also going to be different. So it's determined which interval has the greatest average speed, the average speed, the average rate of change, which is the greatest. Well, one thing to remember is that even once we switch into application graphs, this down here, this axis where it says elapsed time in hours, this is still our x-axis. And the vertical distance traveled, miles, is still our y-axis. That means that all of these points, even though they have different meaning, well, for example, this first point, 140, well, the x value is 1. That means in 1 hour, the distance was 40 miles. In 2 hours, the distance traveled was 110 miles. And you can go all the way to this last point. Well, in 10 hours, the x value, which is hours, and the y value, which is 390 miles, distance traveled. So when we're determining the rate, it's the same exact thing. Our slope is the same as our average rate of change, which in essence still is the change or the difference of our y's over the difference of our x's. So let's just take one of these, and I'll let you do the rest on your own. Let's just take one of these intervals. Let's go between the 6th and the 8th hour. Why not? Let's just go with number 3 and try to figure out what the average rate of change was between the 6th hour, meaning this point right here, and the 8th hour, this point right here. Well, I'm going to take those 2 points out here, and I'm going to put the 6, 230 first. And I'm going to put the second one point, which is 8, 350. And now since we're doing this as if it were the slope formula, this is my first value of x and my first value of y, and my second value of x and my second value of y. First point, second point. Now I'm gonna do this all the way down. I'm gonna do equal sign. I'm gonna come all the way down here, right? And I'm gonna draw a nice big fraction line, and I'm gonna put parentheses, minus parentheses, over parentheses, minus parentheses, and substitute all the numbers where they belong. Well, this first number becomes my y2, which is going to be 350. And this is going to be my y1, which is 230. Well, this underneath here is going to be my x1, which was 6. And this is going to be my x2, which is going to be 8. And my x1, which is going to be 6. Oop, almost made a mistake there. Caught myself. Okay, and then you can put those in the calculator if you like, but it's pretty easy to subtract 350 minus 230, which is 120. And 8 minus 6, which is 2. Now, if you want to put this into context, we know that these y's were distance traveled in miles, and we know that our x's is the amount of hours which have passed by, elapsed, right? So, if we want to understand our first part of the answer here, we could easily convert it into 120 miles were traveled in 2 hours. Well, when we're doing the average rate of change, one thing that we like to do a little differently when we're writing the equation is keep the decimal, right? Let's write it in decimal form, right? So I'm just going to go to my calculator and put the fraction 120 divided by 2. And I'm going to keep whatever decimal if there happens to be one. And we can see, oh, it's just equal to 60. Easy enough. 60. Well, 60 what? Well, we know that when we're talking about the average rate of change in slope, we always put the y's, I'm going to put a little triangle, how the y is changing over how our X is changing. It's always y over x. Well, what were the y's? The y was miles. So it's 60 miles traveled in, well, if there's no number down here, it's as if it's 60 over 1. 60 miles traveled for every hour. Or, as we like to say, 60 miles per hour. And that right there would be the average speed between the 6th and 8th hour. Why don't you go ahead and try 1, 2, and 4 and see which one had the greatest speed?